So after the coagulation, let us now look into another property, that is the surface tension. Now the surface tension is a very important aspect of the property of water, which is happening all the time without our knowledge. So after the coagulation, let us now look into another property, that is the surface tension. Now the surface tension is a very important aspect of the property of water, which is happening all the time without our knowledge. Surface tension is a contractive tendency of the surface of a liquid that allows it to resist an external force. So the surface tension is an important property that markedly influences the ecosystem. The cohesive forces among the liquid molecules are responsible for the phenomena of surface tension. So the surface tension, which is gamma, the magnetic is the magnitude of the force extended parallel to the surface of a liquid divided by the length L of the line over which the force acts. So to put it in simple terms, gamma equal to F by L, where the units are the surface tension are dynes per meter. Dynes are the force and L is the length. So basically it is a force applied on a parallel surface, and the water has the highest surface tension, which is 0.03 dynes per meter, and among the liquids, and this property has a great biological significance. I will give you a lot of examples where surface tension plays a role in daily processes. Surface tension explains water rise in a glass capillary, and which is wet, that is surface is of the glass. This behavior of the liquid is called the capillary action. The second example is in the bulk of a liquid, each molecule is pulled equally in every direction. If you are talking about a water molecule inside the any container within the layer that is inside, then all the water forces are applied equally. For example, on the figure you see the bottom two water molecules have equal forces applying equal direction. Now you see the top one. The top two water molecules are exactly on the top layer. So the above which is the air and below which is the water. So therefore this the force is applied only in one direction and not on the top. Therefore these water molecules do not have other molecules on all sides of them, and therefore are pulled inwards. So this creates some internal pressure, and therefore the forces liquid surfaces to contact to the minimal area. The surface tension is responsible for the shape of the liquid or the droplets. Now again, this is the water on a leaf. You see that it forms a droplet, that is because of surface tension. And in the absence of these forces, including the gravity, the drops of virtually all liquids would be approximately spherical, but the spherical shape minimizes the necessary wall tension of the surface area according to Laplace law. Then again you have surface tension facilitates the water movement or the transport from roots to the leaves, whatever height is the tree, and surface tension, that is air water interface in the substomatal cavity of the leaf, creates a large negative pressure potential, that is psi p, that pulls water up the xylem, and this is one of the examples in the plant biology. Water movement. Now the theory is based on the three key properties. One is a cohesion, the adhesion, and the high surface tension of the water. So these three properties, actually when we talk about the movement of water, we need to consider not only the surface tension but also the cohesion, the ability of water molecules to stick together, then also the adhesion, the ability of water molecules stick to the sides of the tube or the container, and of course the surface tension. See, on the right side I have shown you the hydrogen bonds allows adhesion between water molecules, and evaporation of the cell. Hydrogen bonds allows cohesion between water molecules in the xylem, and then water is moved. Then comes the force called buoyant force. Buoyancy, you must have heard, especially in the swimming pool and all. You see, this is a force applied upward on the object by any fluid. There are number of examples in day-to-day life also. This is actually based on the Archimedes principle, which states that buoyant force applied to an object is equal to the weight of the fluid the object displaces. So, for example, if you put a 10 kilograms of any metal or a weight into the water, what happened? That is displaced. Now you see here because of this 10 kilograms object which is displaced 4 kilograms of water, it feels that like it is only 6 kilograms underwater, but this is because 4 kilograms of water has been displaced. Now this force is called the buoyant force, which is equal to the weight that of the displaced water. So that is the force that is felt by when Eureka, when he said Archimedes principle. This is a picture that located in the MedTech Israel National Museum of Science, where actually he found the buoyant force and he said Eureka. The very good example is how a ship floats in the sea, also cruise, such a huge ones. How do they float? Exactly based on the Archimedes principle. Now we will come to the last property of today's hydrodynamic properties, that is the electrohydrodynamics. Before I introduce to this property, which is not very well known because it is less commonly known, the electrohydrodynamics, it is actually important to just familiarize with this electrical conductivity, because electrical conductivity is not actually a hydrodynamic property, but in electrical current results from the motion of electrically charged particles, because you will be doing the electrophoresis, so I just thought I will mention this here. Therefore, electrical current results from the motion of electrically charged particles in response to forces that act on them from an applied electric field. Within most solid materials, a current arises from the flow of electron, which is called the electronic conduction. Now, in water, the ion, if that is in a solid, but if you take a water, the ions or ionic materials or the fluids, a net motion of charge can occur, and this phenomena produce an electric current and is called the conduction. So, the electrical conductivity is given by S equal to J by E equal to 1 by R, and this is called the current density, that is J, and electrical field intensity E, and of course the opposite of this resistivity is the R. So, conductivity and resistance are inversely proportional. So, of course, electrohydrodynamics is also known as electrofluid dynamics. Here electrokinetics is the study of the dynamics of electrically charged fluids. Now, to put them into summary, let us summarize what we have studied today. What we have understood is what are the hydrodynamic properties of water and how it is important to understand, to know what are these properties before going to do the techniques we are going, not only the next week but to next week also. A large number of techniques which you come across are actually based on hydrodynamic property. So, I explained what are the hydrodynamic properties and what is a colligative property and how an osmosis and a reverse osmosis work in a different examples of the biology, and coagulation in terms of the protein denaturation which leads to coagulation, surface tension which is the most important property by which the water rises, and also the buoyant effect, how the molecules, how the force that is being applied upward on an object by any fluid. These are all the properties of water, most important, and it is very relevant in this context to understand the basics. Otherwise, you will not come across, suddenly you come across one property and then you go back and check in the literature what is this. So, I thought I put them all together, and I have given you some of these definitions and applications which we will be studying. So, I hope you enjoyed the today's class, and thank you for visiting Swayam and attending my tutorial. Thank you.